Imagine standing on the edge of a cliff, not one carved from stone, but from water, a liquid precipice that plunges miles into shadow. The ocean covers more than 70% of our planet, yet it's a realm we've barely touched, a hidden universe where the rules of life bend and break in ways that challenge our understanding. It's not just deep, it's alive with secrets that grow stranger, more unsettling the further you descend. This isn't a tale of monsters from myth, but of real creatures forged by evolution in an environment so extreme it feels otherworldly. As we embark on this mental dive, prepare to feel the weight of the water, the chill of the unknown, and the awe of adaptations that whisper of forbidden truths. Why does the ocean get more terrifying the deeper you dive? Let's descend together, layer by layer, into the abyss. Our journey begins not in total darkness, but in a half-world of fading light, the twilight zone, stretching from about 200 meters below the surface to 1,000 meters deep. Here, the extreme condition is the relentless dimming of sunlight. Picture the sun's rays as fragile fingers reaching down, growing weaker with every meter until the water absorbs them completely, leaving only a faint blue-gray haze. It's like walking into a fog-shrouded forest at dawn, where shapes blur and the air thickens with mystery. In this perpetual dusk, life has had to adapt or perish, and the results are both ingenious and eerie. Consider the lanternfish, a small, unassuming creature that dominates this layer in sheer numbers, trillions of them, perhaps the most abundant vertebrates on Earth. Their bodies are slender, silver-scaled, designed to reflect what little light remains, making them nearly invisible to predators above. But their true marvel lies in the photophores, tiny pearl-like organs dotted along their undersides that produce light through a chemical reaction called bioluminescence. It's as if they've stolen fire from the gods, mixing luciferin and luciferase in a glow that mimics starlight. This self-made illumination serves multiple purposes, attracting tiny plankton for food, signaling to mates in the gloom, or even creating counter-illumination to blend with the faint light from above, turning their silhouettes into shadows. Yet this adaptation only scratches the surface of the strangeness. Each night, in one of the planet's largest migrations, billions of lanternfish ascend toward the surface to feed under the cover of darkness, then retreat at dawn. Why risk the dangers of brighter waters where larger predators lurk? Scientists still don't know the full story. Is it solely driven by the abundance of food in the upper layers, or is there a deeper evolutionary clock ticking in their genes, synchronized with the moon's phases or ancient ocean currents? Observations from deep-sea submersibles like the Alvin have captured glimpses of this vertical highway of life, but the sheer scale, equivalent to the biomass of all humanity, leaves us pondering what unseen forces orchestrate this Bailey ballet. This raises a larger question. If such coordination exists in the twilight, what synchronized horrors await in the depths below? As we push deeper, the twilight gives way to the midnight zone, 1,000 to 4,000 meters down. Now, the extreme condition escalates. Absolute blackness engulfs everything, a void so complete that without artificial light, you'd be lost in an inky eternity. No sunlight penetrates here. It's a realm of sensory deprivation where sight is obsolete and survival demands new senses. The pressure mounts too, equivalent to the weight of a small car pressing on every square inch of your body, enough to compress air pockets and challenge even the hardiest materials. It's like being buried alive under invisible mountains, where the cold hovers just above freezing, slowing metabolisms to a crawl. In this oppressive darkness, the viperfish emerges as a sentinel of terror. Imagine a creature straight from a fever dream, a long eel-like body, black as pitch, with a lower jaw unhinging to reveal fangs longer than its head, curving backward like scythes. These teeth aren't for show, they're precision tools for ambush hunting. The viperfish hangs motionless, its bioluminescent lure, a glowing barbel dangling from its chin, mimicking a helpless worm to draw in unsuspecting prey. When something bites, the jaws snap shut with lightning speed, the fangs impaling the victim before it can escape. Its eyes, oversized and tubular, are adapted to detect the faintest glimmers, perhaps from other bioluminescent flashes or the rare beam from a submersible. But how does it navigate this sightless world? Beyond vision, viperfish likely rely on lateral lines, sensitive canals along their bodies that detect vibrations and pressure changes, like a built-in radar for the fluid chaos. Some studies suggest they might even sense bioelectric fields, the faint electrical signals emitted by living things, turning the ocean into a web of invisible currents. This adaptation feels almost supernatural, a product of millions of years of evolution in isolation. Yet it deepens the mystery. Why such exaggerated features? Fossil records hint at ancient predecessors in shallower waters, but what cataclysmic events, perhaps shifts in ocean chemistry or mass extinctions, drove them into the deep? Expeditions like those of the Ocean Explorer have filmed viperfish in action, their strikes a blur of ferocity, but we've only observed fragments. What full predatory dances unfold in the unlit expanse? Scientists speculate on symbiotic relationships with bacteria that power their glow, but the evolutionary path remains a puzzle, a lingering shadow in our knowledge. Descending even further, we enter the abyssal plains, vast, flat expanses from 4,000 to 6,000 meters deep. Here, the extreme condition is scarcity. Food is rarity, trickling down as marine snow, decomposing particles from the surface world, falling like a slow, eternal blizzard. Temperatures plummet to near freezing, and the pressure intensifies to levels that would implode most submarines. It's a desert of darkness where energy conservation is key and life clings to existence with minimal expenditure. The gulper eel embodies this harsh minimalism with a twist of the macabre. Also known as the pelican eel, it possesses a mouth that dwarfs its body, unhinging to form a cavernous pouch capable of engulfing prey several times its size. Its stomach, elastic and expandable, acts like a living storage bag, allowing it to feast on infrequent windfalls, a dead whale falling from above, or a school of fish wandering too deep. The eel's body is ribbon-thin, almost translucent, minimizing drag and energy use in the sparse currents. Bioluminescent spots along its tail might serve as lures or distractions, flashing to evade threats. This grotesque efficiency prompts an unanswered question: why the prevalence of giantism in abyssal dwellers? Nearby, colossal squids roam with tentacles stretching up to 43 feet, eyes as large as basketballs, adaptations perhaps for spotting prey in the dimmest bioluminescent flickers, or for efficient propulsion in cold, viscous water. Theories abound. The Bergman's rule suggests larger bodies retain heat better, but in the deep, it's more about metabolic slowdown. Or is it a response to rare, high-stakes encounters where size ensures dominance? Discoveries from remotely operated vehicles like the Kaiko have retrieved squid beaks from sperm whale stomachs, hinting at epic battles in the depths. But live observations are scarce. The abyss's isolation, separated by vast distances, means populations evolve in pockets, potentially harboring unique subspecies we've yet to classify. What we've discovered only deepens the mystery. Could these giants hold clues to undiscovered food chains reliant on chemosynthetic bacteria rather than sunlight?
Our final plunge takes us into the Hadal Zone, the trenches, plummeting beyond 6,000 meters to depths like the Mariana Trench's Challenger Deep at over 10,900 meters. The extreme condition here is incomprehensible pressure, over 1,000 atmospheres, equivalent to the weight of the Eiffel Tower on your thumbnail. Water compresses everything, temperatures hover at 1 to 4 degrees Celsius, and oxygen is sparse, drawn from surface mixing eons ago. It's the closest Earth gets to extraterrestrial hostility, a crack in the planet's crust where the mantle nearly peeks through. In this crushing void, the snailfish defies logic. These unassuming tadpole-like creatures have bodies of jelly, soft gelatinous tissues that yield to pressure rather than resist it, preventing implosion. Their skins lack scales, and their bones are minimal, flexible frameworks. Enzymes and proteins in their cells are specially folded to function under such force, drawing from piezophilic adaptations where molecules stabilize in high-pressure environments. Some species glow faintly, perhaps to communicate in the total blackout, while others scavenge on amphipods or bacterial mats around hydrothermal vents. This resilience leaves a profound, lingering mystery. What other life thrives in these isolated trenches? Probes like the Nereus have captured footage of translucent snailfish gliding ethereally, but many trenches, Kermadec, Puerto Rico, remain barely explored. Hydrothermal vents spew mineral-rich fluids, fostering chemosynthetic ecosystems where bacteria convert chemicals into energy independent of the sun. Giant tube worms, blind shrimp, and microbial mats hint at parallel evolutions, but could there be larger predators, unseen leviathans adapted to the fissures? Seismic activity and toxic outflows add peril. One misstep and a submersible could be lost forever. Scientists still don't know how these isolated pockets exchange genes. Do larvae drift on currents, or are they evolutionary islands? The Hadal Zone's inaccessibility underscores our limits. With technology barely scratching the surface, what forbidden truths lie buried? As our imagined ascent begins, pulling us back through layers of increasing light, reflect on the journey. From the twilight's glowing migrations to the midnight's fanged ambushes, the abyss's elastic survivors, and the Hadal's gelatinous ghosts, each depth reveals adaptations that feel alien yet are profoundly earthly. Evolution's response to extremes we can scarcely comprehend. These creatures aren't horrors, they're masterpieces of survival, reminding us of life's tenacity in the face of oblivion. Yet, the ocean's terror lies in its vast unknown. We've mapped the moon more thoroughly than our own seas. Less than 5% of the deep has been explored. Submersibles like the limiting factor have reached the bottom, but fleeting visits yield only snapshots. Climate change stirs the depths, warming waters, acidifying chemistry, potentially disrupting these fragile balances. What we've discovered only deepens the mystery. How do these ecosystems interconnect with our surface world? Could deep-sea microbes hold cures for diseases, or do they harbor pathogens waiting to rise?
In the grand cosmic scale, humanity is but a fleeting spark on the ocean's surface, gazing into an abyss that mirrors our own ignorance. The deeper we dive, the more terrifying it becomes. Not because of monsters, but because it exposes how little we know about our home. The ocean doesn't terrify with jump scares, it unsettles with whispers of endless possibility, inviting us to explore, to wonder, and perhaps to fear what revelations await in the uncharted blue. As the surface breaks and light returns, carry this with you.